uh, let me see, is it working properly or not? Yeah, I think it is working properly. So let me start. So today we're gonna solve the assignment 6. Okay, then start from the question number 1. So in question number 1, let me question number 1, if a coin tossed a fair coin tossed 3 times. A fair coin tossed 3 times. Let x denotes the number x denotes the number of heads, and y denotes the absolute difference between number of heads and number of tails. Now we have to find the probability of getting one head, given that the difference between the number of heads and tails is 1. So you have to calculate that. So let's solve this problem. So let's first discuss about how many possible differences there may be. So in 3 tosses, one 3 tosses, there are 2 yeah, Ravi Shankar, you are right. In 3 tosses, HHT and TTH. Yeah. Yeah. So let me discuss it again. That in 3 tosses, how many differences is possible. So we actually try to find the sample space of y. How many possible value y can take. So it may happen that 0 head appear and 2 tails we get after the 3 tosses. We get 0 head and 2 tails, or maybe 2 tails 0 heads, or maybe 1 tail 2 head, 1 or 2 tail 1 head. So only these things are possible, other things are not possible. Sorry, this is not true. So 0 heads, 0 we get 0 head and 3 tails, or 3 heads 0 tails, 1 head 2 tails, or 2 head 1 tails. This is only the thing that we can get. So that means what is the possible absolute difference between the number of heads and tails? This is 3 or 1. So y can take value only 1 or 3. So 2 minus 1 is 1, 2 minus 1 is 1, 0 minus 3, or 3 minus 0, its absolute value is 1. So y can take value 1 to 3. Now let's see how many possible values x can take. So x can take maybe 0 head appear, maybe 1 head appear, 2 head appear, or maybe 3 head appear. These many possible heads can we can get this many possible head. So make a table. Let us make a table. Okay. So this is y. Y can take value 1 or 3. This is x. X can take value 0, 1, 2, 3. So this is my total sample space. Now let's see, uh, is it possible that I get a 0 head and the difference between head and tail is 1? It is not possible, right? Because if I get 0 head, that means in the 3 tosses consecutively I get tail. That means 3 tail I get. So 3 minus 0 is 3. So 1 is not possible. So this I getting 0 head and the difference between the number of tails and head is 1. It is not possible. So that means the probability of occurring these events is 0. Yeah. Okay. And 3 is, so let's see what is then 3 is possible with getting 0 head and 3 is possible. So how many times I will get that? So total equally likely events is 2 to the power 3. So 8 things may occur. 8 possible things may occur. Out of them, one possibility is 0 head and 3 tails. So this is the probability is 1 by 8. Now similarly, if I get 1 head out of the 3 trials, can I get the difference 1? Yes. If I get 1 heads and 2 tails, that means if I get 1 heads and 2 tails, the difference is 1. So this is possible. So let's say, so out of 8, there are 3 this is head tails or something like that, but we know already the difference is 1. So that means we know out of these 3, 2 are tails and 1 is head. So how many possible ways I can arrange this? So this is 3c1. So out of 3, how many ways I can arrange 1 tail? So 3c1. So this is actually 3c1 by 8. So this probability will be 3 by 8. Now this is not possible because I already tell if I get 1 head, that means 2 already are tails. So that means 3, difference between that things 3 is not possible. So 2 head 1 tail. So this is again possible. So this will be the similar 3 by 8. So 2 head and 1 tail. So 2 head and 1 tail. We again can arrange them in 3c2 ways, and 3c2 means 3. And 2 3, it is not possible again. Now if I get 3 heads, so what is the probability? 3 heads, 1 by 8, but the difference between the 3 heads will be actually 3. That means tails in the trials I get 0 tails and 3 heads. So that means 1 is not possible. This probability is 0. This is 1 by 8. Now if we sum along row, we'll get the probability of probability of x. So these will give probability of x. So what is the probability that this event occur, that p x equal to 0 is 1 by 8. Similarly, this is 3 by 8. This is 3 by 8 again. This is 1 by 8. And if I sum the along the row along the column, we'll get this is 3 by 4. This is the probability of y equal to small y. So p equal to 1 will be the probability, the difference is 1 is 3 by 4 and the difference is 3 is 1 by 4. if you sum these, and if you sum these 1 8 plus 1 8, 1 by 4, 3 8 by 3 8, so this will be this is 1 by 4 plus this will be 3 by 4, so this is 1, and again this is 1 also, so this is 1. So this is my table. Now we have to calculate what? We have to calculate first the marginal probability, since uh, we have to know that what is the probability that px equal to 1, y equal to 1. So we have to know the marginal probability. From the probability theorem we know that pxy is nothing but joint probability pxy, right? Px. So we know the pxy from the table, so we have to calculate what is the value of px, which we have already mentioned in the table. So let's see what is the value of this px equal to 1, x equal to 1, y equal to 1. This is py. So pxy, so we have to see, we will see what is the value of pxy, that means both are 1 1, so 1 1. Right, yeah, so I have corrected it. So p11, so p11 means 3 by 8, okay, by py equal to 1, right? Py equal to 1 is 3 by 4, and p11, what is the value of p11? 3 by 8, so this is 3 by 8 by py equal to 1 will be 3 by 4, 3 by 4, so this is 4 by 8, this is half, so the probability is half. So this is the first question. Find the probability px equal to 1 given that py equal to 1, that it gains its half. Now move toward the second question. Question number 2. Let x and y be two continuous random variable, and the joint probability distribution of the x y is x 1 minus x minus y if x greater than equal to 0, y greater than equal to 0, and x plus y less than equal to 1, or otherwise elsewhere 0. So that means now we have to calculate, again we have to calculate the expectation value of y given that x equal to 1/3. Let us see that. So in which region? So this means if we draw in this lower region, the probability is non-zero only in this region, in this lower region, okay, in this region probability is. Now we have to calculate to evaluate the expectation value, we have to know the this conditional probability, that is, again we know that probability of x comma y by probability of this gonna be x. That means we already know the joint distribution of pxy, we have to know the marginal probability at x. So let us calculate what is the marginal what will be the marginal density function at x, that is integration xy dy. Now what is the range of y? So range of y, so this is y, this is x, so range of y means if I take any arbitrary line, so y goes from 0 and in this point, since it's satisfied this x plus y equal to 1, that means in this point what is the value of y? Y is 1 minus x. So for arbitrary x, what is the value of y y going from 0 to 1 minus x? So that is the limit. Now let's calculate it. This is 0 to 1 minus x, 6, 1 minus x minus y dy. So this is 6, 1 minus x into y minus y square by 2, and the limit goes from 0 to 1 minus x. So this will be 6, this is 1 minus x its square minus 1 minus x its square by 2. So this is 6 into 1 minus x whole square by 2. So this is 3, 1 minus x its square. Now we got fx. Now what will be the what will be the density function at y equal to density function of y given that x equal to x, that is f of x y by f of x. So this will be, so let me see, at x equal to, okay, at x equal to, okay, leave it as it is. So this is nothing but if we put it here, 6, 1 minus x minus y by 3, 1 minus x its square. So this is 2, 1 minus x minus y by 1 minus x square. Now we have to calculate the probability density function y given that x equal to 1/3. X equal to 1/3. Now if I put it here, so this is 1 minus 1/3 minus y by 1 minus 1/3 square. This is 2 into 2/3 minus y by 4 by 9. So this is 9 by 2, 2/3 minus y. Now what is the expectation of y given x equal to 1/3? That is nothing but integration. And what is the limit of y? So for if x equal to 1/3, suppose this value of x is 1/3. So what is the limit of y? Y is going from 0 to 1 minus x, then 0 to 2 by 3. So, and outside that region, outside this region, in all other points, the density function will be 0. So we need not to integrate on those region, because on those region integration value will be always 0. So we have to calculate only 0 to 1 minus 1/3 y into f of y given x equal to 1/3 dy. So this is 9 by 2, 0 to 2/3 y 2/3 minus y dy. So this integration results is, it is 2/3 y square by 2 minus y cube by 3, 0 to 2 by 3. So 9 by 2 into 2/3 into 4 by 9 into half minus 8 by 27. Yeah, so am I correct? Let me check it. Okay, this will be 9 by 2 into, so I think something is I think something is not right. Okay, so there are another 3's there, right? These 3 is there, that I missed. Y cube by 3, y cube 2, 8 by 27, 1/3. So this is 1/3. This is 4 by 9 minus 8 by 27. 8 by 27. So this is 9. This is 3 by 2. 3 by 2 into 27 into 12 minus 8. So this is 3 by 2 into 4 by 27. 2 is 9. So the answer is 2 by 9. So that's that is the solution of the question number 2. Let's move toward the question number 3. Now question number 3. Uh, 8 by 81. Okay. Ravi Shekhar, can you check your answer again? It's not, I think it's not 8 by 81, it's 2 by 9. Now, suppose a two-dimensional random variable x and y, suppose two-dimensional these two random variable takes values, these takes values I comma j, where I can take 0, 1, 2, and j also can take the value 0, 1, 2. Now, what is the probability, since it's a discrete probability, so what is the probability that it will take probability, what is the probability that x equal to I, y equal to j is simply ci plus j. Now, it is given that which of the following option is not correct. So the option A is expectation of x equal to expectation of y. B is variance of x equal to variance of y, and C is small c is equal to 1 by 118, and D is expectation of x is equal to 2/3. So let's check. So first of all, from here, since I and j both take same value, so what is the probability? Okay, let me write it. That first, let us calculate the value of c. As we know, if I sum over the whole space, it should give us 0, 1. X, y equal to j should be 1. If I equal to 0 to what, 0 to 2, j equal to 0 to 2. Let's see. So this is I equal to 0 to 2 is j equal to 0 to 2, c I plus j to 1. So I can write I can write 0 to 2, j equal to 0 to 2 I plus I equal to 0 to 2, j equal to 0 to 2 j is 1. Now what is the summation? Said not answer missing term. Shekhar, what are you trying to say? I didn't get your point. Sir, not answer missing term. Are you saying that my answer is not correct, or okay, okay? Oh, you were saying okay, 1/3. I Shekhar, can you? Okay, 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 fine. So this is that. So in this summation there is no j involved, only I involved. So we can take this summation j equal to 1 to 2, and first we'll sum over I, and what value I take only value 0 plus 1 plus 2. Similarly here also only sum or j will be taken care by this sum, and I equal to 0 to 2. So this is 0 plus 1 plus 2 is 1. And how many this term will be added? 3. So this summation means, so this is 3, this is 3, so 3, I have to add 3 times 3, so 3 plus 3 plus 3 here, and this summation also 3 plus 3 plus 3 is 1. So this is 9 plus 9, 18, c into 18 is 1. So this is and this is c is 1 by 18. So we already got that c is 18 is correct. This is correct. Now let's check the expectation of x. So since we have to calculate the expectation of x, so let's calculate the expectation of x. Okay. Expectation of x. Now, to calculate expectation of x, we have to calculate the what is the probability of x, right? So this is nothing but summation of y p x comma y. So this is summation y can take value, or j can take value 0 to 2. 0 to 2 ci plus j. And you can see first term you will get, we have in the first term, so let me write it like it, j equal to 0 to 2 I plus c equal to 0 to 2 j. So this is c, and 0 to 2 means since in this sum there is no j involved, I have to add 3i, so that will give 3i, and then summation over this will be 0 plus 1 plus 2, so this is nothing but 3c I plus 1, and we know c is 1 by 18, so let's put it here, 1 by 6 I plus 1. Now what is the expectation value of x? So that will be summation of I equal to 0 to 2, I equal to 0 to 2 I into probability of I. So that is 0 into probability of 1 plus 1 into 0 into probability 0, 1 into probability of 1, 2 into probability of 2. So this term will be not there, so 1 into probability of 1, so we put 1 6, 1 into 1 6 to 1 plus 1 plus 2 into 1 6 2 plus 1. So this is 1/3, this is 1/3 into, so this will be 1, so 4/3. So the expectation of x is 4/3. Now from the form of the probability distribution function, that is ci plus j, you can see that this is symmetric. If I replace y and x, the probability distribution will not change. So from there you can easily tell that the expectation of x and expectation of y will be same. So since this probability distribution function is symmetric, that means if I change I by j, j by I, then this probability distribution function remains same. So that means the expectation of x will be same as expectation of y, and the variance also, variance of x will remain same as variance of y. So that means these two are correct, these two are correct, only this C, the D is not correct. So that is not correct, as we calculated the expectation value of x is 4/3, so that is not correct. So let move towards the question number 4, or if you have any question. Okay, you don't have any questions. Okay. Question 4. Now let x and y is a bivariate random variable such that its correlation coefficient, or its correlation coefficient exists. This exists. Rho is the correlation coefficient. Correlation coefficient. Now there are several statements, so which are correct and which are not. So let me put the statement up below here. So rho x comma y, if the correlation coefficient 0, does it implies x and y independent, x and y okay, x and y independent b x and y independent implies rho x comma y is 0. C, if x comma y follows bivariate normal distribution with some coefficients, then x and y are independent if and only if rho xy is 0 and t is rho up is 0, where p is u square and u follows a standard normal distribution with mean 0 and standard deviation 1. Now which among them are correct? So rho xy 0 implies x and y independent. No, this statement not correct. Rho xy 0 means they are not dependent in linear manner, they are uncorrelated. So rho xy0 means you cannot write x as a linear function of y, x as a linear function of y, linear function of y. It means that it doesn't imply that x and y are independent. It may be happen that x equal to y square. So for a these also rho x comma y equal to 0, but this doesn't imply that x and y are independent. So a is not true. And in the second question, so x and y independent implies rho xy0. Yeah, it implies rho xy0. If x and y actually independent variable, then you cannot write a linear you can write x as a linear function of y. So let us check. You can also check mathematically. Rho xy, what does it mean? It means expectation of x x into y minus expectation of x into expectation of y. And if x and y are independent variable, then expectation of x into y can be written as expectation of x into expectation of y minus expectation of x expectation of y. So this is 0. So this is true statement. So this is true, this is false. Now if x and y is bivariate normal, then x and y are independent if and only if rho xy0. Yeah, this is true because independence demand that moment generating function of x and y, I'm writing symbol correctly or not, moment generating function x and x and y yes, moment generating function x and y at suppose t comma s should be moment generating function of x at point t, moment generating function y point s. Now for bivariate normal distribution, this moment generating function, as it has already been taught in the class, so I think in lecture number 8, lecture number 7. So this is this in left hand side it is m x t m y s into e to the power, I think, rho sigma 2 st. I think this is correct. Let me check. So yeah, rho sigma 2 st. So this side will be that, and this side is mxt mys. So you will see that from here the independence condition will be satisfied if and only if rho is 0. So that means this statement is true. Now let's see that statement D, that rho u is 0 where v is u square, that statement. So let's calculate the rho. It is u square u p, which is rho u square. So expectation value of u square minus expectation of u square. Now since this u follows a standard normal distribution, that means the expectation of u is 0. So this term is already 0, and this term is expectation of uq. Now you know, you already know that this normal distribution is symmetric about the 0 point. So and to integration means this expectation of uq means integration of minus infinity to plus infinity uq into normal distribution 0 1. So here suppose this suppose du. So this is a even function, this is a odd function, so integration minus infinity to plus infinity, these will be 0. So that means this actually 0. So uv is 0, so that means fourth option is also true. So that is true. Now this is that question we have already solved. So let's move toward the question number 5. Or someone ask any questions here? No, that's fine. Okay, now we move towards the question number 5. Okay, question number 5. Question number 5 is following, that raindrops fall at random on a square. Square is with vertices 1 0 0 1 minus 1 0 0 minus 1, and outcome is the point xy in is struck by a particular raindrop. Let random variable x y is x, and random variable y x y is y coordinate of that point, and assume that x, y has uniform distribution over S. That is, joint probability distribution function PDF functions of xy is, if xy is half if coordinate belongs to S, 0 elsewhere. The problem, if I pictorially draw the problem, the statement is following. So suppose this point is 1 0, this point is 0 1, this point is minus 1 0, this point is minus 0 minus 1. So this is the plane AS, and if you drop raindrops are coming in this surface, and any raindrop fall in the surface randomly, and if it fall here, suppose this point is xy, and the distribution of this xy is this form. So now we have to again, here there are some there are some statement, we have to say which statements is correct. So find the correct option from the below. So expectation of x is less than expectation of y. B, variance of x is less than variance of y. C, x and y are not independent. T, x and y are independent. So to choose a correct option among the A, B, C, D, we have to calculate first what is the marginal probability of x and y. So let's calculate that first. So we have to calculate the marginal probability, right? So let's calculate what is the marginal probability. So we have to calculate fx and fy. So you see this region is a very interesting region. So the we have to do the integration very carefully, because the limits are not straightforward here, integration limit. So x will be have to integrate dy. So now we can divide this region into two parts. First we have to integration first, let's see in this region. Okay, let me use another color. So in this region, so this region is 0 to in this region x 0 x varies from 0 to 1, and what y varies here, y varies. So for any x, for any arbitrary x, from where to where this y goes. So first let me write what is the equations of this line. So this equation, the equation of this line will be, so this line will be, so x by 1 plus y by minus 1 is 1. So this means this equation is x minus y equal to 1. Here it is simply x plus y equal to 1. Here equation of this is x right, x by minus 1 plus y by 1 is 1. So this means y minus x equal to 1. This is y minus x is equal to 1, and this cuts x at minus 1. So x by minus 1 plus this cut y at minus 1. So y by minus 1 is 1. So that means minus x minus y equal to this equation, minus x minus y is equal to 1. Now you see from here to here, what is the value of y here? Value of y is, at this point value of y is y 1 minus x, and value of this point, I think it is wrong. So this is, I think y is x minus 1 here, and what is the value of here is, here y is 1 minus x. So you see here the what possible value y can take for a given x, that is y equal to x minus 1 to 1 minus x, 1 minus x, right? And what is the range for which this is true? For x belongs to 0 to 1. So that's it. Now let's do the integration. Fxy, what is the value of fxy? It is simply half. So half x minus 1 to 1 minus x dy. So see, half into 1 minus x plus 1. So this is nothing but 1 2 into 1 minus x by 2. So this is 1 minus x. So that's it. So that's it. The fx in the PDF or the probability density function between 0 to 1 is 1 minus x by 1 minus x. Similarly, let us calculate what is the probability density function in this region. in this region, in this region. As we did the calculation here, y for arbitrary x, what value y can take? Y can take y here, y is equal to -1 minus x, here -1 minus x, to here 1 plus x. So if x is here also half y equal to -1 minus x to 1 plus x, if xy dy, so half into, this is simply 1 plus x minus of 1 plus x, so this is 1 plus x. In what region? In region what value x can take? From -1 to 0. So this is valid for -1 greater than x greater than 0, this 1 greater than x greater than 0. So in this region this is true. Now let's calculate similarly the distribution, marginal distribution of f of y. So let me calculate f of y at y. So now you see, now we have to calculate the y integration. We have to integrate x. So f of xy dx. Does anyone ask any questions? Okay, you have, sorry I didn't said x and y be independent variable with common probability density function e to the power x, and which of the following is not correct? U and v are independent. Okay, you want to answer me this question? Okay, let me see. So okay, see, let x and y be independent random variables with common probability density function fx equal to e to the power minus x, where x greater than 0. Let u is equal to x plus y, and v let u equal to x plus y into v, or then which one is the not correct? U here independent, y into v. Okay, y into v. U here not independent, are independent. V is in distribution on the 0 to 1 is exponential distributed, and the joint distribution, yes. Okay, I will try to solve this question. Let me first solve the questions which are there in u is equal to, okay, u is equal to x plus y, and v is equal to okay. Can you write it in the message? I didn't, your voice is not clear, so that's the problem. X by x plus y. Okay, okay, okay. And v, what is the function? Means I didn't get what v is equal to. V is equal to x plus y, or x by x plus y. Both u and v is equal to x plus y. Okay, x by x plus y. Okay, I got it. So I will try to solve this question. First I solve the assignment which has been in the previous year assignment, then I will try to solve this question. Okay. fxy, so this is tx. So here we have to integrate we have to take here the limit of x. So now see, in the similar manner, we here will take for arbitrary y, will separate it out in these two regions. So from in one regions we will integrate here. So here x values, what is the values of x here? X is -1 minus x, and here is x is, okay, I think here x is your value of x is 1 minus y. Okay, this is 1 minus y minus 1 here. Here the x values is 1 minus y. So this is from y minus 1 to 1 minus y, or -1 plus y to 1 minus y, and it is half again. So this is 1 minus y minus 1 plus y, okay, plus 1 minus y. Okay, this is 1 minus y. So this in the region for y equal to 0 to 1, 0 y 1, and if y is in this region, suppose in this region, here it is y is, here x is minus x is -1 minus y, and here x is 1 plus y. So let me write it, -1 minus y to +1 plus y, f of x y dy, that will be 1 plus y. Now, and this is valid for -1 y less than 0, right? Okay. Now you see the distribution of fx and fy are same, since what is the distribution? Fx at in this region, okay, let me see here, in the region where x belongs, x is between 0 to 1, it is 1 minus x, and similarly when 0 to 1 it is 1 minus 1, and in -1 to 0 it is 1 plus x, in -1 to 0 it is 1 plus y. So the distribution of x and y are same. So that means the expectation of x should be equal to expectation of y, and the variance of x should be equal to variance of y. And the thing is, another thing is, x and y are independent. If x or y independent, so we should get fxy should be fxx into fyy. So if we multiply, suppose in this region 0 to 1, 1 minus 1 multiplied by 1 minus x, so these will, so 1 minus x and 1 minus y, 1 minus x multiplied by 1 minus y. And you see that in this region, what is the probability, joint probability distribution, which is half. So that means if xy not equal to fx into fy, that means these variables are not independent. So that means this answer is correct. So only x and y are not independent, that answer is correct. Now let's move toward the question number 6. Think. Okay. Question 6. Question 6 is u, v are this type of function, cos alpha, sine alpha minus sine alpha, this is cos alpha. So this means u equal to cos alpha into x minus mu x and sine alpha into y minus mu y. So v equal to minus sine alpha x minus mu x plus cos alpha 1 minus mu y. These things. Now we have to check the independence condition of u and v. Okay. Now we have to calculate for which values of alpha these u and v are independent. So let's calculate that. So for independence, as we know, these x and another thing are there, okay, which I have been missed here. So here another thing is required, that x and y are bivariate normal distribution with coefficient mu x mu y rho sigma x sigma y sigma x sigma y rho. Now we know that for a normal distribution, bivariate normal distribution, the linear combinations of these also are uninormal. U should be an uninormal distribution, and V also normal, not bivariate. It's a univariate normal distribution, univariable normal distribution. So the condition of u and v, the independence condition of u and v is that if its correlation coefficient is 0 or covariance is 0, then we can say that u and v are independent. Now let's calculate the that condition. That expectation first. Expectation of u is you see. Okay, let me write it. Expect cos alpha expectation of x minus mu x plus sine alpha sine alpha into cos alpha expectation of x minus mu x plus sine alpha expectation of y minus mu y. And from it is given that the expectation of x is mu x, so this is 0 and this is also 0, so that means e of u is 0. Similarly, e of v is also 0, and we have to calculate to e u and v. U multiplied by v. So let us calculate. So uv means expectation of cos alpha x minus mu x plus sine alpha y minus mu y into minus sine alpha x minus mu x plus cos alpha y minus mu y. So expectation, so if I expectation of minus cos alpha sine alpha x minus mu x square plus cos square alpha x minus mu x y minus mu y plus minus sine square alpha y minus mu y x minus mu x plus sine alpha cos alpha y minus mu y square. Now from the additive property of the expectation, we know that this is nothing but sine 2 alpha by 2, and expectation of this term is nothing but sigma x square plus cos square x, expectation of x minus mu x into y minus mu y, and minus sine square alpha sine square alpha, expectation of y minus mu y x minus mu x, and then this term is again sine 2 alpha by 2, and this is sigma y square, and this is the covariance. The covariance a expectation of x minus mu x, this is covariance, and covariance of x comma y means rho into sigma x into sigma y. So if we put it here, so far we get sine 2 alpha by 2 sigma x square plus sine 2 alpha by 2 sigma square plus this is also rho sigma x sigma y, and this is also rho sigma x sigma. So if we take common, so cos square alpha minus sine square alpha, sine square alpha, this is cos 2 alpha, cos 2 alpha. So these for independent condition, these terms would be 0. So this 0 means sine 2, sorry, 0 means sigma, yeah, sigma x square minus plus sigma y square by 2 sine 2 alpha plus rho sigma x sigma y cos 2 alpha should be 0. So that means sine 2 alpha by cos 2 alpha equal to rho sigma is sigma y by this sigma x square minus sigma y square by 2. So that is 2 rho sigma x sigma y sigma x square minus sigma y square. So that is tan 2 alpha means 2 rho sigma x sigma y by sigma x square minus sigma y square. So that is the answer. Now let's move toward the next question. Question number 7. Okay. Question number 7 is following. So if xy is following 1 by pi root 3 e to the power minus 2 x square minus xy plus y square by 3. So if it is so, find the expectation of y given x equal to small x. So I have to do that. So this looks like a bivariate normal distribution. Let's find its coefficients. So let's write it in this fashion. So 1 by 1 pi 2 pi root 3 by 2. So let me write it. What is the bivariate normal distribution. Let me write it here so then it will be clear. 2 pi sigma 1 sigma 2 root over 1 minus rho square exponential minus 1 by 2 root over 1, sorry, 2 1 minus rho square x minus mu 1 by sigma 1 its square plus y minus mu 2 by sigma 2 its square minus 2 rho x minus mu 1 y minus mu 2. Okay, let me see it. Did I write it correctly or no? Yeah, okay, by sigma 1 by sigma 2 by sigma 1 by sigma 2. Now if we compare these two, we get from here 1 by 2 1 by 2 1 minus rho square is equal to 2. So that means 1 minus rho square is 1/4, which means rho square equal to 3 by 4. That is rho means root 3 by 2. And from here if you compare, what is the value of mu 1? Mu 1 is 0. Mu 1 is 0. What is the value of mu 2? Mu 2 is also 0. Mu 2 also 0. What is the value of another thing? What is the value of sigma 1? Sigma is 1. Sigma 1 is 1. What is the value of sigma 2? Sigma 2 is root 3. And let's multiply these things. It should come minus x minus 1 coefficient. So if I multiply 2 into rho root 3 by 2 into 1 by 1 into 1 by root 3, so this come as 1. So that means I got the all variables that I need, and let's put it here. If I put it here, sigma 1 sigma 2 is root 3, and this is 1 minus rho square is 1 by 4. So if I put it here, 2 pi sigma 1 sigma 2 into root over 1 minus rho square. Root over 1 minus rho square means this root, so half. So this is root 3 pi. So we actually got the all the coefficient we needed. So now you can easily write the distribution function of y, that is y given x equal to x, that is 1 by root 2 pi sigma 2 root over 1 minus rho square. Okay, so not write it here. This is simply a bivariate normal distribution with coefficient that mean sorry, this is not bivariate, this is only a normal distribution with mean mu 2 plus rho sigma 2 by sigma 1 into x minus mu 1, and standard deviation is 1 minus rho square into sigma 2 square. Its variance is this. So this is my normal distribution. Now what I have to calculate, what is the expectation value of x. its expectation value, and if we put the all the coefficient I got, mu2 is 0, so this is 0. Rho is root 3 by 2, so this is root 3 by 2. Sigma 2 is root 3, this is 1, this is x, this is 1 minus rho square means 1/4, and this is sigma square, it's 3, so 3/4. That means normal distribution with mean 3 by 2x and variance 3 by 4. So now it is easy. What is the expectation value? Expectation value of y at x equal to small x, that is this mean, which is equal to 3 by 2x. So that is its answer. Now let's move toward the next question. Question number 8. Yeah. Okay. Question number 8. Okay, question number 8. Question 8. Now here x and y are bivariate normal distribution. X and y bivariate normal distribution with coefficient mu x equal to 1, sigma x equal to 1, mu x equal to 1, mu y equal to 1, sigma x equal to 1, sigma x square equal to 1, sigma y square equal to 1, and rho is equal to half. So this is the bivariate normal distribution. Then the distribution of y is y x equal to 2 and x y equal to what? So this is very simple. We already know what is the distribution. So distribution of x given y, x y is equal to y, is a simple univariate normal distribution with mean mu x plus rho sigma 1 by sigma 2, sigma 1 by sigma 2, y minus mu x 1 minus mu x, and its variance is sigma 1 square 1 minus rho square. So this is, and if I put it put all the values, that is a normal distribution, mu x is 1 plus rho is half, this is 1 1, and y minus 1, this is 1, and 1 minus 1, and 1 minus 1/4 is 3/4, and f of y given x, y x is normal mu y plus rho sigma 2 by sigma 1 x, this is mu y, x minus mu x, sigma 2 square 1 minus rho square. So this is normal distribution. Put it similarly, I think all the things are similar, so these also be same, half x minus 1 on 3/4. Now it is asked that what is the distribution at y given x equal to 2. So if we put x equal to 2, it will become x equal to 2, it will become n 1 plus x equal to 2. If I put x equal to 2, okay, I missed something. I think this is okay, let it, I think what it is 1 plus x equal to 2, that will be half, and this is this, and this is 3 by 4. So this will be normal distribution with mean 3 by 2 and variance is 3 by 4. And if other thing is here, y x equal to 2, then we'll get, if we put it here, that distribution will be normally distributed, and it is also same. So this is also 3 by 2, 3 by 4. So that's it. Now move toward the question number 9, and at last I will try to solve the question which has been asked by the Sekhar. Question 9, that is, there is given a joint probability distribution xy is k 3x plus y. This is 0, where 1 then less than 3 and y 0 0 less than equal to y less than equal to 2 and in elsewhere. Now we have to calculate the correlation function x y. To calculate that, calculate the correlation coefficient function. So first we will calculate what is the value of k, and we know that if we integrate it out, it's simple integration 1 to 3 and 0 to 2 if x y, this is x equal to, this is y equal to dx di should be 1. So that means integration 1 to 3, 0 to 2 k 3x plus y dx dy equal to 1 k 1 to 3, 0 to 2, 3x dx plus y 1, oh sorry, y dy 1 0 to 2 1 to 3 is 1. Okay, this is x square by 2 and a dx into dy dx. So this is dx is 1 to 3 3x dx into 0 to 2 dy, really 1 to 3 dx do 0 to 2 y dy 1. Okay, this will be 3x square by 2, 3x square by 2, 1 to 3 multiplied by 2 plus this is also multiplied by 2 into y square by 2, 0 to 2 should be 1. Okay, this is actually, if we do it, so we'll get, this is 28k. If you do it, you will get it is 28 28k is 1 and k is equal to 1 by 28. Now we have to calculate for the correlation coefficient function. To calculate, we have to know the covariance of xy. To covariance of xy, we know that covariance xy means expectation of xy minus expectation of x into expectation of y. So to calculate the expectation of x and expectation of y, to calculate the expectation of x and expectation of y, we have to know the marginal distribution function. So let's calculate the marginal distribution function. So that will be integration over y range is 0 to 2, that is 0 to 2 k 3x plus y dy, this is k, 3xy 0 to 2 plus y square by 2 0 to 2. 1 by 28, 3x, 6x, this is 6x, and this is 4 2 2, so that is 1 by 14, x is 3x plus 1, and calculate fy. It will be 1 to 3, 3x plus y dy. This will be k, 3x square by 2, 1 to 3 plus y 2y. Sorry, this is dx. This is 1 by 28, 3 into 3 by 2 into 9 minus 1, so 8. Basically this is 8 plus 2y. So this is 1 by 14, this is 4, so y plus 6. Now what will be the expectation of x? That is 1 to 3 small x f of x dx, so that is 1 by 14 integration 1 to 30 3x plus 1 dx, so that is 1 by 14 3 into x square by 2 plus 2, so that is 1 by 14 into this is, it is 1 to 3, so 9 minus 8, so it is 12 plus 2. I think I got it wrong somewhere. Aha, so I didn't multiply it with x. Yeah, so that's why it's becoming 1, it's not. So so that is 1 by 14. First term is x cube by 3, so x cube. Second term is x square by 2, and it's 1 to 3, 1 by 14. This is 27 minus 1, 26, plus this is 9 minus 1, 8 by 2, 4, that is 30 by 14, so that is 15 by 7. So expectation is this. Similarly, calculate expectation of y, that is 0 to 2 y f of y dy is 0 to 2 y 1 by 14 y plus 6 dy, 1 by 14 y cube by 3 plus 6y square by 2, so that is 3, 0 to 2 1 by 14. This will be 8 by 3 plus 3 into y square means 4, 12. So that's it. Think did I get it right? So let me check. This is y square with 3y cube plus 63y square by 2. So this is 412, and you will see it is y square plus is 2. What it is, let me calculate it. 14 into 3, 8 plus 36, 44 by 14 into 3. Okay, 2, 22, 7. So 22 by 21. So it is correct. Okay, now let's calculate the expectation of xy, x into y. So that will be 1 to 3, 0 to 2, x, y, f x comma y, dx dy. So 1, 3, 0 to 2, x, y. F x y is 1 by 28. 1 by 28. Yeah. That is 1 by 28, 3x plus y. 1 plus 28, 3x plus y. 3x plus y dx dy. 1 by 28. First integration will integration with respect to y. So if I integrate, the first term will be 3x square y square by 2. Second term is plus x y cube by 3, 0 to 2 dx. 1 by 28, 1 to 3, and if I put 2, 4 to 6x square plus 8x by 3 dx. 1 by 28, this is 6x cube by 3, so 2x cube plus 4 by 3 x square 1 to 3. So this will 28. First term will be 8 minus 1 7 14 plus 4 by 3 and 8. So 1 by 28 into 42 plus 32 by 3. So this is 42 plus 32, it is 74 by 28 into 3. This will be 47 by 21. Now another thing we have to calculate, that is expectation of x square, that is variance. We need this term because so this is 1 to 3 x square 3x plus 1 by 14. So this is 1 by 14, that do dx, x cube by 3, so simply x4 by 4, 3 by 4 plus x cube by 3, 1 to 3. So this is 103 by 21, and similarly expectation of y square is 0 to 2 y square y plus 6 by 14 dy. This will be 10 by 7. Now simply the correlation coefficient is expectation of xy minus expectation of x into expectation of y by root over of variance of x, variance of y. This is variance of x, this is variance of x, this is variance of y. So if we put it all together, it will came 0.0211. So that is the answer. Now let's this is the last question of this assignment. So question number 10. So question number 10, it says that the x and y follows a bivariate. This is a follows a probability density function which is given below. If xy is 1 by 2.4 pi exponential of minus 1 by 0.72 x minus 1 by 2 its square plus y minus 2 by 1 its square minus 1.6 x minus 1 by 2 1 minus 2 by 1. So from its form we can easily direct that this is a bivariate normal distribution with the coefficient. Let us calculate the coefficient. Coefficient first is 1 by 2 into root over 1 minus rho square is equal to 1 by 0.72. So that means 2 1 minus rho square equal to 0.36 square. And from that the rho value of rho is 0.8, I think. Okay, let me calculate it. Rho square is, okay, 1 minus 0.36 its square. So rho is root over of this 1 minus 0.36 into, let me, okay, I think is it correct? So let me check it once. Calculator. Okay, point 0.36 into 0.36 minus 1 . Sure. Okay. Oh, I did mistakes. One thing I not get, that this root is not there, so that means this is that 1 minus rho square means 0.36, so rho means 1 minus 0.36, so rho is, this is 0.6 for root over of 0.64, this is 0.8, and mu x, value of mu x is 1, sigma x is 2, mu y is 2, and sigma y is 1. So we got all the value. Now the question is, we have to find the expectation of x, that is simply mu 1. Expectation of y, that is simply 2. And covariance means, let me write covariance of x and y is rho into sigma x sigma y, and its rho is 0.8, sigma x is 2, sigma is 1, so that is 1.6. so that is the answer of this question. And I will try to solve the Krishna's questions. If I, okay, you have put two questions, one question, okay. So Krishna, okay, let me check it. Let x and y be identical independent random variables with common probability with common probability. So x and y, these two are independent random variable, identical independent identical independent distributed random variables with common probability density function fx e to the power minus x. So she is saying that there are two variables x and y. X follows, x and y both follows same distribution, e to the power minus x. Okay, e to the power minus x. Okay, let me e to the power both follows probability of density function. It is PDF, right? It's probability density function. Fx is e. Fx is e to the power minus x, and fy also e to the power minus y. Common probability density on this. Let u is equal to x plus y. U is x plus y. X plus y. P is equal to okay, b is equal to x by x plus y. P is equal to x by, and p is equal to x by x plus y. Y p is equal to now u and v are independent. Okay, u and v are independent. P is uniformly distributed on the interval. Okay, is there any con? Okay, v is uniformly distributed on the interval 0 to 1. Oh, x greater than 0. B is correct, right? B is already correct because x plus y and x1 both greater than 0. That means x by x plus y. So B is actually correct. We have to check the u and v are independent or not. U is exponentially distributed. The distribution of u. Now, since here the distribution of u we can easily calculate because moment generating function of this variable, suppose t u, what it will be, expectation of e to the power x tx plus y. So this is expectation of e to the power tx plus ty. Moment generating function pu, it is yeah. So and the moment generating function of these two variable, its joint distribution is not given, right? So Krishna, does this fx uh, and fy are same, you are saying, and this question doesn't say about its joint distribution. So I don't know how one going to solve this. Obviously B is correct, there is a no worry about that. B option is correct, which is not correct. B is correct. U is exponentially distributed. U is exponentially distributed, and the joint distribution of UV is if UV U comma V is U e to the power U e to the power minus U. Well, let me calculate first moment generating function. This is simply the moment generating this is simply the moment generating function x comma y. So we have to calculate what is the probability of mxy if x comma, okay, so that means what will be the fx we know that fx is if x comma y ty. This means if x comma y small xy will be partial derivative of y respect of fx plus some constant which is content gx. It's some content, so that means fx should be this will be that, and again if xy, this is also true. uh, Krishna, I don't know how to solve it. Let me think it. I will solve it in the next class because I don't see how I gonna solve it. Yeah, if okay, then I think it is the end of this tutorial, and I will try to. Okay, let me take a screenshot of these so that I can try to solve it. Okay, if is there anything else you can ask me, or you can leave. There is nothing to add in this tutorial. So that's it. Or if you have no question, then I can quit this session now.